All right, so this is 7-9, and this is more graphing. All of these equations are going to deal, or should deal, with degree, and the numerator being the same degree as the denominator. I'm going to show you the tricks for this. In my geometry class, I try and hammer through to them that math really is more explainable through color, which was kind of what I was trying to get at with the project. We were almost there. Not quite. I'm going to show you how color usually helps me. When we get one of these equations, there's two things we can tell from the original form. All right, we can tell the y-intercept and we can tell the horizontal asymptote. The y-intercept is determined by the fraction of our constants right here, okay, or my purple circle. So if I take this over, this is -1 over -3, which is just equal to 1/3. Okay, this means I have a y-intercept at 0. Okay, because it's always x equals 0 for the y-intercept, comma 1/3. Okay, there's 1 point. The next thing I can tell by looking at this equation, since they have the same degree, if I look at the coefficient right here, and what I need to remember is that there's invisible ones. Okay, I have a horizontal asymptote at my orange. So the fraction I'm looking at is 1 over 1. This means I have a horizontal asymptote at y equals 1. Okay, so the first thing I can do is come over to a graph, and I can plot these things. So I know there's a horizontal asymptote, and I've done that in orange. So I'm going to come here at 1, and I'm going to mark that I have a horizontal asymptote here. The next thing I'm going to mark is take my purple, and I know that I have a y-intercept right around here, 0, 1/3. That's about 1/3 of the way up. The next thing to do is to change this into our factored form. So up on top here, we have difference of squares. That's going to change into f of x equals x plus 1 times x minus 1. If I factor the bottom, I'm going to get x plus 3 times x minus 1. Now that I'm in this factored form, I need to ask, what are my special x's? And I can go through and I can make a list here. What happens when x equals 1, or one of these factors? So if x equals 1, I'll get a 0 over 0, which implies a whole. I'm going to come by with a new color, and I'm going to underline this as green. Okay, my next special x is what happens when x equals -3. This will recreate some number over 0, which implies a vertical asymptote. I'm going to come in with blue, color that. I have one more special x. And we haven't talked about this yet, and this is one of the new parts. Just like we had the y-intercept up here in purple by circling our constants, if we have a factor up here that only makes the top equal 0, so if x equals -1, that only makes the top 0, which implies a x-intercept at -1, 0. For x-intercepts, the y component is always 0. I'm going to come through and I'm going to color this pink. Okay, I have 3 new colors here, so I want to come and add that to my graph. The first thing I'll add is my asymptote. So at -3, I'm going to put in my blue vertical asymptote. Okay, next I'm going to take pink, and I'm going to say at -1 I have an x-intercept. Okay, and I'm not going to do my hole yet because I'm not quite sure where it goes on the graph. But if I were to guess, it looks like, just by graphing these 2 points, that this is going to head up towards the intercept, or towards the asymptote, and head down towards the vertical asymptote. Next thing I'm going to do is I'm going to look at the simplified form here. Again, since I cross these out, it implies a hole. But I've already shown that over here. Looking at this graph, I'm left with f of x equals x plus 1 over x plus 3. I can go and make a table of this function if I would like. However, again, just by graphing these 2 points, I can tell that this is increasing towards the asymptote and coming this way towards the asymptote. Since these graphs are symmetric, I know I can come up to this quadrant and draw another graph like this. If I wanted to, I could come by and make the table for x equals -4 and see what I actually get as my coordinate. I don't want to forget my green here. I don't have green on the graph yet. So I'm going to come back to x equals 1 and notice that, oh, well, I have a hole here. So I'm going to make a nice big hole. Okay. Again, this is nice. I was able to graph these by only plotting 2 points in my asymptotes and knowing what had to happen just by the fact this is increasing. This whole section is just going to be more graphing. I recommend trying at home over the weekend f of x equals x squared minus 4x plus 3 over x squared minus x minus 6. And don't forget, if you want to check how these are supposed to look afterwards, go to Desmos.com. But remember, Desmos doesn't show holes. So you need to make sure you recognize where the hole should go. If you have any questions or comments, please send me an email. Besides that, have a lovely weekend and come ready to graph on Monday.